Welcome to this session. This session you solve these two problems. One is the integral of cosine of ln of x dx, and the second one is x cos of 5x minus 1. Now, in these two integrals, especially the first one, we have to be very creative in order to transform it into a more proper format of the integrand that will help us to do the integration without problems. So in the first one, integral of cos ln of x dx, we say let x be given by e raised power y minus pi over 2. So we make this substitution so that cosine of ln of x will be the same as cosine of ln of e raised power y minus pi over 2. And then you see laws of logarithms, ln of x raised power m is the same as m ln of x. So this is the same as cos of y minus pi over 2 ln of e. And you see ln of e is 1. So this is the same as just cos of y minus pi over 2. And we know from this identity that cosine of a minus b is the same as cosine of a times cosine of b. When there's minus, then plus sine of a, sine of b. So which means this is the same as cosine of y, cosine of pi over 2 plus sine of y and then sine of pi over 2. And you see cosine of pi over 2 is 0. So this part will be 0, and sine of pi over 2 is 1. So 1 times sine y is just sine y. So which means that cos of ln of x, the substitution x equals to e raised power y minus pi over 2 is the same as sine of y. So i.e. cos of ln of x is the same as sine of y when we use the substitution x equals to e raised power y minus pi over 2. And then, so we want to transform the integral cos of ln of x dx to be purely in terms of the new variable y. So where there's cos of ln of x, we replace by sine of y. And from this one, dx is the same as differentiating this one, we get e raised power y minus pi over 2 dy. So this is the same as integral of sine of y and then times e raised power y minus pi over 2 and then dy. I remember from laws of indices, if I have e raised power y minus pi over 2, can be written as e raised power y times e raised power minus pi over 2. So this integral can be written as integral e raised power minus pi over 2 e raised power y sine of y and then the y. I remember e raised power minus pi over 2 is a constant, so we can factor it out. E raised power minus pi over 2 integral e raised power y sine of y dy. Now you see with that transformation, we have an integral whose value we can easily find. So we'll be now dealing with the integration of e raised power y sine of y dy. Now here we use integration by parts quite easily. So let u to be given by sine y, and let dv be given by e raised power y dy. Or we can even let u to be e raised power y and dv to be sine y dy. We still get the same answer. So du will be cosine of y dy, and v, when you integrate this one, you get e raised power y. So remember, we have integral of integral of u dv is uv minus integral of v du. So which means integral of e raised power y sine of y dy is uv. So u is sine y, v is y, e raised power y. So we'll have e raised power y sine of y minus v du. So this v, this is du. So integral of e raised power y, and then cosine of y dy. So you see this second term in the integral also dictates us to apply integration by parts again, this part here. So let's call this one integral I. So integral of e raised power y cosine of y dy equals to, so let u to be cosine of y and dv to be e raised power y dy. So du will be negative sine y dy, and v, integrating this, you get e raised power y. So integral of e raised power y cosine of y dy is uv. This by this will give us e raised power y cosine of y minus v du. But so these negatives will be plus integral of e raised power y sine of y dy. Now you see this part is the same as what we have as I. So I can just write this the same as e raised power y cosine of y plus this integral is I. So replacing the solution into this integral, we'll have I is the same as e raised power y sine of y minus, so this part we have e raised power y cosine of y, and then plus I. When you simplify, you get e raised power y sine of y minus e raised power y cos y, and then minus I. So we're opening the brackets here. And then remember, we are solving for I. So take this to the left, we'll have 2I equals to e raised power y sine of y minus e raised power y cosine of y. So which tells us that I alone will be a half e raised power y into sine of y minus cos y. So, and then plus a constant of integration c. So that is the integral of this part here. But remember, the whole integral was e raised power minus pi over 2 times the value of the integral. So this implies integral cos of ln of x dx is e raised power minus pi over 2 times a half e raised power y, and then you multiply by sine y minus cos y, and then plus, let me call this one c1. So this e raised power minus pi over 2 times c1 just give us another constant c. So which can be written as a half. Now loss of indices is the same as e raised power y minus pi over 2 into sine of y minus cosine of y is plus c. But you see, from our starting point, this is the same as x, so we'll have a half x, and then sine of y from our calculation, sine y was the same as cosine of ln of x, so we'll have cosine of ln of x, and so cos y should be sine of ln of x, and then you add the constant of integration c. Remember, what is making us to say cos of y is the same as, say, cosine of at this point here, when you say e raised power, just to convince yourself that cos of y is sine of ln of x, we have said that e raised power y minus pi over 2 is the same as x. So which means cosine, so ln of x is the same as y minus pi over 2. So this, by definition, from this one, we have that. Now, if you define sine on both sides, so sine of ln of x is the same as sine of y minus pi over 2. And you see sine a minus b is sine of a cos of b minus cos of a sine of b. So this is the same as sine of y cos of pi over 2 minus cos of y, and then sine of pi over 2. So this is 0, and then you have minus cosine of y, and then times 1. So which would give us minus cos of y. So by the way, in fact, this now sign is plus. This sign is plus. Because now I have minus minus. So which means sine of ln of x is the same as sine of y minus pi over 2, which is the same as minus cosine of y. So therefore, cosine of y alone is the same as minus sine of ln of x. So therefore, when you replace where there's cosine of y by minus sine of ln of x in this point here, so the negative sign will change to plus, and so the value of the integral will be a half x into cosine of ln of x plus sine of ln of x, then you multiply by, and you add the constant of integration c. So this is the solution to that problem, and this sign is plus. And finally, the second part, we have the integral of x ln x integral of x cos of 5x minus 1 dx. So we let u to be x and the v to be cosine of 5x minus 1 dx. So this means the u will be dx and v will be the integral of cosine of 5x minus 1 dx. And when you use substitution method, this one will give you v to be 1 over 5 sine of 5x minus 1. So integration by parts will give us integral of x cosine of 5x minus 1 dx uv. So we'll have 1 over 5 x sine of 5x minus 1 minus v du. So we'll have factor out this 5, 1 over 5, and then sine of 5x minus 1 dx. And then using substitution method, we can find this part. So we'll have 1 over 5 x and then sine of 5x minus 1 and then plus. So remember, when you differentiate sign, you get negative cos, negative plus. So 1 over 5 and then times 1 over 5 in this substitution, and then cosine of 5x minus 1, then plus a constant of integration. And on simplification, we have 1 over 5x sine of 5x minus 1 plus 1 over 25 cosine of 5x minus 1 plus c. You can decide to factor out 1 over 5, 1 over 25, so it'll be 1 over 25 into, now this will be 5x sine of 5x minus 1 plus cosine of 5x minus 1 and then plus constant of integration c. So the problems of integration, you have to be very smart to see how you can transform the given integral into a form that can be easily integrated for you to get the answer. As we have seen from the first question, that transformation of x equals to e raised power y minus pi over 2 has really helped us to reduce the integrand into solvable form. So that's usually the way you have to go when you have an integration problem. Try as much as possible to transform the integrand into a form whose solution you can get without having some difficulties. Thank you.